Welcome to AJ Akshar Academy YouTube channel. In this session, I am going to discuss laws of motion. In this laws of motion, second law of motion. If you like this video, please subscribe to our channel. Please share your valuable comments in the comment section. Second law of motion, that is Newton's second law of motion. Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the applied force and takes in the direction of the force. See, observe these pictures. The second law of motion tells that there is a net external force acting on a body. It relates to the net external force and the acceleration of the body. So, the second law of motion tells us there is a net external force acting on a body. It relates to the next external force and the acceleration of a body. Now, acceleration is produced when a force acts on a mass. The greater the mass of an object,
to cause an object to accelerate or speed up, a force must be applied. The more force you apply, the quicker you accelerate. Look at these two swings. If you apply the same force on both swings, check whose goes faster. Let's first push the little kid. See? It goes very high. Now push this fat man with the same force. See, it does not go far, because it has more mass than the little kid. So the more mass there is, the force required to push the object is also great.
So, more mass, more inertia. Here, when the force acting on a mass, the greater the mass of object, the greater the amount of force required to accelerate the body. Okay. Next, acceleration is produced when a force acts on a mass. So, the greater of the mass objects, the greater is the amount of force required to accelerate the object. So, everyone unconsciously knows the second law. Everyone knows that heavier objects require more force to move the same distance than lighter objects. So, heavier objects, if you want to push the heavier objects or if you want to move the heavier objects, we have to apply more force on it. For lighter objects, for less force. Okay. What does this mean? So, Newton's second law gives us an exact relationship between the force, mass and acceleration. So, Newton's second law gives the relation between force, mass and acceleration. It talks about how fast an object moves. Mathematically, second law can be expressed as F is equals to ma, that is product of mass and acceleration. F or force is equals to mass into acceleration. Newton's second law of motion is the most significant law among the laws of motion. Second law measures quantity of force, whereas the first law of motion describes concept of motion. So, first law of motion describes concept of force and the second law measures the quantity of force. Now, let us discuss units. In CG system, the unit of force is gram, centimeter per second square or dyne. In MKS or S system, kilogram, meter per second square or Newton. So, the relation between these two is 1 Newton is equals to 10 to the power of 5 dyne or 1 dyne is equals to 10 to the power of minus 5 newtons. So, now we will define 1 Newton. We know that F is equals to ma. If m is equals to 1 kilogram and a is equals to 1 meter per second square, then F is equals to 1 kilogram into 1 meter per second square, that is 1 kilogram meter per second square, that is equals to 1 Newton. So, if a force produces an acceleration of 1 meter per second square on an object of mass 1 kilogram, then the force is called 1 Newton. Mass 1 kilogram and acceleration 1 meter per second square, then the force is called as 1 Newton. its dimension formula of force is mlt to the power of minus 2. Now let us discuss examples. Ramu's car, which weighs 1000 kilogram, is out of gas. Ramu is trying to push the car to a gas station and he makes the car to move with an acceleration of 0.05 meter per second square. Using Newton's second law of motion, you can compute how much force Ramu is applying on the car. So here we have to find the force, and mass m is equals to 1000 kilogram and its acceleration a is equals to, they given as 0.05 meter per second square. Now F is equals to ma. So F is equals to m nothing but 1000, a nothing but 0.05. So F is equals to 1000 into 0.05. Now F is equals to 50 newtons. Here 1000 we can written as 1000 into 0.05 can be written as 5 by 100. 0 gets cancelled. 10 into 5, 50 newtons. Okay. Now let us discuss MCQs. First one. Which of the following is the most significant law of motion given by Newton? Third law of motion, second law of motion, first law of motion, Newton's law of gravitation. So in these four options, second law of motion gives the most significant law of motion by the Newton. Okay. Here F is equals to ma. This is about the Newton's second law of motion. This is the most significant law of motion given by Newton. Okay. Next. A force produces an acceleration of 1 meter per second square on an object of mass 1 kilogram. This force is defined as 1 dyne, 1 Newton, 1 Tesla, 1 Poundal. So this is 1 Tesla. Here it is, answer is 1 Newton. If a force produces an acceleration of 1 meter per second square in an object of mass 1 kilogram, then the force is called 1 Newton. So this is 1 Newton. Okay. Now derivation of Newton's second law of motion. Let us discuss. Statement of Newton's second law. The rate of change of momentum of a body is directly proportional to the applied external force and takes place in the direction of force. This is about the Newton's second law of motion. So this statement tells that the rate of change of momentum of a body is directly proportional to the applied external force and takes place in the direction of the force. So let us have an expression for Newton's second law. If under the action of external force F bar for the time interval dt, the velocity of a body of mass m changes from v to v plus dv. So then its initial momentum p is equals to mv changes by dp is equals to m into dv. So according to Newton's second law, the rate of change of momentum of a body is directly proportional to the applied external force and takes place in the direction of force. So F is proportional to dp by dt. So if you remove the proportional, you put a constant. So F bar is equals to k into dp bar by dt. Here k is proportionality constant. So that is equals to k into p can be done as, that is initial momentum, dv. So F bar is equals to k into m dv bar by dt. dp is equals to m into dv. So F is can be written as k into m dv by dt. F is equals to k into m dv by dt. So this here m is constant. F is equals to k m a nothing but acceleration, that is dv bar by dt. So A bar is equals to dV bar by dt. So F bar is equals to K into MA bar. If K is equals to 1, then F bar is equals to MA bar. This is Newton's second law of motion statement. Mathematically, it can be written as F bar is equals to MA bar. Okay. Now we'll discuss units of force. Force F is equals to MA. So in C system, gram, centimeter per second square or dyne. In SI system, kilogram, meter per second square or Newton. So 1 Newton is equals to 10 to the power of 5 dyne. Now its dimensional formula of force is ml t power minus 2. So ml t power minus 2 is the dimensional formula of force. Now gravitational units of force. Kilogram weight and gram weight are called the gravitational units of force. So 1 kilogram weight or 1 kg of kilogram force, that is equals to 9.8 newtons. 1 gram weight or gram force, that is equals to 980 dyne. Now I'll discuss MCQs. First one, what is the relation between force and acceleration? Directly proportional, inversely proportional, equal, none of these. So the relation between force and acceleration are directly proportional. Here force is equals to F is equals to ma, therefore F is directly proportional to A. Okay. Next, what is the SI unit of force? Dyne, Newton, Newton per second square, Newton per second. The SI unit of force is Newton. Here in SI system, the unit of force is Newton. Okay. Thanks for watching this video. Thank you.